Alright, so what makes today different than the other day? It's this whole f of x thing, or the y. If I've got y equals the absolute value of x, what we're going to have, like Dorothy said earlier, we're going to have a graph, right? Not a number line, because we've got x and y. We've got a y-axis, we got an x-axis, right? So we both have x and y, we're going to have to graph it, okay? And we just did our t-table, right? So if x is negative 3, we've got a value of negative 3. Negative 3 goes in for the absolute value, so the absolute value of negative 3 is 3, right? So we'd have a point at negative 3, 3. And then if we did the absolute value of negative 2, the absolute value of negative 2 was 2, positive 2. So we'd have an answer of x is negative 2, and y would be a positive 2, right? Same thing, if absolute value of negative 1 is 1, so we'd have an answer of negative 1, 1. And we found out that we wound up getting this particular graph right here, okay? We got our v, because if you plug in 0, you get 0. If you plug in 1, you get 1. If you plug in 2, you get 2, because that's value 2. So you get this v, okay? This is what we call the parent function, okay? The parent function, okay? It's the basic, it's the main graph. And all we're going to do with the main graph is move it. We're going to translate it, move it around. We've done this before, so this shouldn't be too hard, okay? Now, is it a function? Because I called it a parent function. Is this thing a function?
Yes.
Now, how do you know it's a function? It'll pass that vertical line test. Every single x value has only one y value, right? So it is a function. Good job. So now, let's go ahead and take this graph, and we're going to go ahead and move it down 4, right? We're going to take this parent graph, we're just going to move it down 4. So we're going to go 1, 2, 3, 4. That's all we're going to do is take the graph and move it down 4. So I take the vertex, I take its vertex, that's its vertex right there, and I'm simply just going to move the vertex, right? When I move the vertex, it's easier to move the whole graph, so I take it down 4, and I can still get this 1, 1, 2, 2, right? Oops, I'm a little off. Now, domain and range. Okay, one more time, domain. How wide, or what are all the possible, two ways to think about domain. One is how wide is this graph, or the second thing is what could you put in for x? Could you put anything in?
No.
Is there anything you couldn't put in?
It'd be infinite.
Yeah, it'd be infinite. You can put everything you want in. There's nothing that would stop us from putting any x in. So the domain is infinite. But we're going to write it like this. You're totally right. Dylan, if you put that on a test, as if you put infinite, I would take it. This is easier. I'm going to put this cursive R, which stands for all real numbers, right? All real numbers. Every number can be an answer. You can plug in any number. You can plug in any answer you want, okay? Now the range is a little bit different, okay? There's a little bit different with the range because the graph starts at negative 4 and goes up, right? There's no part of the graph that goes below it. Remember, reach for your range. Your range is your how tall. So if I'm at negative 4 and I go up, that's my range. But there's no values below that. So my range is just going to be y is greater than or equal to negative 4, right? Starts at a negative height of negative 4 and goes up, okay? That's easy, right? Starts at a height of negative 4 and goes up. Now, zeros. There and there. Those are my zeros. My zeros are where the graph has a height of 0. So my zeros are there and there. My zeros are where the graph has a height of 0, okay? So my zeros in this particular graph happen to be at 4, 0 and negative 4, 0. Those are the zeros, okay? Not too bad. Shift it up. Example 3. Hopefully you guys remember that if it's on the inside, it is a horizontal shift. We're going to go back and forth, right? We're going to take our v, we're going to take our parent function, absolute value, and we're going to move it back and forth. We're going to take this and just move it back and forth. Now we always go the opposite direction. The reason we go the opposite direction is the value of 2 would zero it out. If I put 2 right in here for x, wouldn't that zero it out? So the value of 2 would have to give us its lowest spot. So I take this graph, I'm going to move it this direction 2 spaces. So I take my absolute value graph, I take the vertex, I move it forward 2, and then I go ahead and graph it in. All right, domain. What's the domain? Domain.
It would be
How wide is this graph?
infinite or all in numbers?
Yeah, x equals all real numbers because it's infinitely wide. There's absolutely nothing x cannot be. But the range is a little bit different, right? What's the bottom height? What's the bottom height?
So it would be y is greater than or equal to negative or 0.
0. Bottom height of 0, and then it goes up, right? Zeros. Actually, I should say just 0 because it only has 1 0, right? It has 1 0, and that's right here at 2. So the 0 is at 2 comma 0. It only has 1. It's possible to have no zeros. You guys agree with that? It's possible. Okay, easy so far? Okay, example 4. Let's take our parent function absolute value graph. We're going to move it twice. First of all, we're going to do the opposite. We're going to move it forward to the right 1, okay? Okay, so we're going to move it to the right 1, and then we're going to move it up 2, all right? So let's take our vertex and move it over 1 and up 2. It's right there, okay? And we'll graph it in. 1, 1, 2, 2, 3, 3, just like that. There we go, like that. Okay. It's not too hard, right? Domain. How wide is this graph?
All real numbers.
So it seems like that's always going to be the domain, isn't it? In fact, it will be. Domain, because you can plug in anything you want, any value. You can plug in any x value. So the domain is going to be all real numbers. Seems to be that's the way it always is, right? How about the range, though? What about the range?
Y is greater than or equal to positive 2.
Yes. Veronica? Zeros. What do you think? Does it have any zeros? It has no zeros, right? None. You guys agree with her? Never crosses, so it has none. No zeros. Nice job, Veronica. Okay, guys, ready to turn the page? Am I going slowly enough? Not too hard. This stuff's pretty easy, right? Here we go. Ready? Turn the page, all right? All right. This one, we're going to do 3 things. We are going to take it up 5, right? I'm going to take it to the left 3. And what's this negative going to do to it? Make it upside down and flip it, okay? So we're going to flip it. We're going to flip over the x-axis or it's upside down. Okay, so first of all, let's find the vertex. Okay, the vertex has got to be at -3, 5, okay? The vertex is at -3, opposite of the inside, 5, okay? So I'm going to get my vertex first. -3, 1, 2, 3, 4, 5, okay? There it goes, okay? Now, we need our absolute value shape. We need that V, right? But we're going to make it upside down. We're going to flip it, okay? So we're going to take our graph and draw it upside down. Okay. Domain.
It would be
How wide is it?
all real numbers.
Yeah, it's all real numbers. In fact, it always is. It seems to be all real numbers, doesn't it? What about range? Now, range is different.
Would it be y is less than
Y is less than or equal to
positive 5?
positive 5. Nice job, Dylan. Nice. Zeros? Two is 0 because the 0 is right there. And 1, 2, 3, 4, 5, 6, 7, 8. How about -8, 0? Okay, those are your zeros. That's easy. Okay, we're almost there, huh? All right, example 6. All right, what we're going to do is our vertex, you ready? The vertex is going to be at 3, -5. 4, right? Because I took the opposite of that, right? Took the opposite. So my vertex is at 3, negative 4. 1, 2, 3, 4. Okay? That makes sense? Now what does this 2 do? Anybody remember what this 2 does? It's going to make it twice as tall. So it's twice as tall, it makes it skinnier, okay? Twice as tall. So it's going to make it twice as tall. So from here, from my vertex, instead of 1, 1, remember 1, 1, I'm going to go 1, 2. So it's going to be twice as tall. It's going to look like that. Domain. Come on, domain's going to be getting easy, huh, by now? Yeah, it's just all real numbers. I mean, even though it doesn't look like it's forever wide, it really will be. And it's always going over, right? You guys agree? It's always moving over. Even though it's going up, it's always moving over. So domain, x equals all real numbers. What about range? What about range? Reach for your range. What's your range?
Y is greater than or equal to negative 5.
4, but you got the right idea. Nice job. Zeros?
1, 0.
Yep. And?
5, 0.
Yep. Nice job, Dylan. Perfect. Okay. Now, example 6. Let's play Jeopardy. Okay. Let's make the equation. So, basically, we're going to take the absolute value graph. We're going to translate it 5 to the left and 3 up. So it looks something like, you don't have to graph it, but I'm going to. Okay. I'm going to go 5 left. 1, 2, 3, 4, 5, and up. 1, 2, 3. So it's going to be there. Okay. It's going to be there, right? That's basically what the graph looks like, okay? But I want the equation. I want y equals. What's the equation? Well, it's got to be the v. What kind of graph is the v? What kind of graph is the v? What kind of graph are we talking about? What kind of graph are we talking about? If it's the v, what kind of graph are we talking about?
Vertical.
Absolute value. It's got to be an absolute value, right? You guys agree with that? This is an absolute value graph, right? X. Now I took it back 5, right? Opposite. Remember how we did the opposite? So I'm going to go x plus 5, took it back 5. I know that doesn't make any sense, but plus 5, took it back 5 because negative 5 would zero it out. And then plus 3. All right. You may have your 3-minute cell phone break.